Okay, parallel lines and the angles that they form. In order to go on with this lesson, we're just going to review what parallel lines are. If you recall, parallel lines are going to be on the same plane. So let's look at plane ABC. And they're going to be two lines that go on infinitely in both directions, and they never intersect. Then you have what are called skew lines. Skew lines are going to be on different planes. So let's look at line AD, that's on plane ABC, and then let's look at line HG, that's back here on this back plane. And because they're on different planes, they're called skew because they're never going to intersect. Alright, a transversal. A transversal is going to be a line that intersects two or more lines. So, if you look at line O right here, do you see how it intersects line M and line L? So line O would be the transversal of line M and L. Transversal is a line that intersects two or more lines. In order to recognize a transversal, we want to find the two lines that are intersected by just one line. So the first question is, what is the transversal of lines L and M? Well, here's line L, here's line M, and you see that line O intersects line M and line L. So the transversal of L and M would be line O. What about the transversal of lines M and O? So here's line M, here's line O, and if you notice that M is intersected here by line L, and here O is intersecting by line L. So L is the transversal of M and O because L intersects the lines O and M. So line L. Okay, two lines that are intersected by a transversal. See, these two lines have been intersected by this transversal. When that occurs, we're going to have a whole bunch of different angle pairs. The first angle pair is called alternate interior angles. Alternate interior angles are a pair of angles on opposite sides of the transversal. So here's one side of the transversal, here's the other side of the transversal. But they're inside the two lines. Alternate interior angles look like a Z. So this angle 6 and angle 3 form alternate interior angles. And then if we create a backward Z, angle 5 and angle 4 are alternate interior angles. So our examples are angle 3 and angle 6 and angle 4 and angle 5. When you're trying to recognize alternate interior angles, find the Z. You can have a backward Z or a forward Z, and your alternate interior angles lie inside the cusps of that Z, here and here. So backward Z, angle 4 and angle 5, and backward Z, or right side Z, angle 6 and angle 3. The next angle pair is called alternate exterior angle. They're going to be on opposite sides of the transversal. So here's the transversal. You're going to have one on this side, one on this side, and they're outside the two lines. So angle 1 and angle 8 are going to be an example of alternate exterior angles, and angle 2 and angle 7 are an example of alternate exterior angles. And the way I remember it is, I imagine that this line is my body, and this is one of my hands, and this is the other hand. If I can extend my hands in opposite directions, those are my alternate exterior angles. Our next angle pair are called corresponding angles. And they're called corresponding angles because they are in corresponding positions. That means they're in the same positions. So they're lying on the same side of the transversal. So here's my transversal. They're going to all be on the same side of the transversal depending on what you're looking at. And they're situated the same way but on two different lines. So let's look at angle 1. It's on the left side of my transversal and it's the top left angle. So I'm going to find the other one that's on the left side of my transversal on the top left angle. So angle 1 and angle 5. Okay, let's look at angle 3. It's on the left side of the transversal and it's on the bottom left corner. So is angle 7. Left side of the transversal, bottom left corner. So angle 3 and angle 7 are corresponding. Now let's look at the right side of my transversal. Angle 2 is on the top right corner, and so is angle 6, top right corner. So angle 2 and angle 6. And then we have angle 4, which is on the bottom right corner of the transversal, and so is angle 8, the bottom right corner of the transversal. So angle 4 and angle 8 are corresponding. So a key to recognizing a corresponding angle is to first find an angle, angle 1, and then go on the same position on the line below. Same position, left corner, line below. So 1 and 5. Top right corner, angle 2. Same position but on the line below, angle 6. Those are my corresponding angles. Okay, consecutive interior angles are going to be the pair of angles on one side of the transversal inside the two lines. And you know the word consecutive, it just means one right after the other. So same side of the transversal inside these two lines. Inside these two lines. So angle 3 and angle 5 are consecutive interior. Let's go on the right side of my transversal. Right side of the transversal, consecutive, one right next to the other, inside the two lines. So angle 4 and angle 6 are consecutive interior. And the way I remember consecutive interior is if you highlight consecutive interior, you form a C, and then if you keep highlighting the other form of consecutive interior angles, it forms an I for consecutive interior. So they're going to be here, and they're going to be here. C and I, consecutive interior. Okay, so go ahead and take a second and list all the pair of angles that fit the descriptions. Find your corresponding angles in this picture here. Pause the video. You should have gotten 1, top left corner, go one line below, 3, top left corner. 2 and 4, 2, bottom left corner, one line below, 4, bottom left corner. 5, top right corner, 7, top right corner, and 6, bottom right corner, with 8, bottom right corner. Okay, pause the video and identify your alternate exterior angles. Remember, that's as far as you can go on opposite sides of the transversal. We have angle 1 with angle 8, opposite sides of the transversal, far outer sides, and angle 4, or angle 5 and angle 4, as far as you can go on opposite sides of the transversal. Okay, pause the video and identify your alternate interior angles. Remember, we're looking for the angles that lie inside the cusps of your forward and backwards Z's. So we have forward Z, angle 2 and angle 7, and then we have our backward Z, angle 6 and angle 3. And go ahead and pause the video. We're looking for our consecutive interior angles, so the ones right next to each other inside the two lines. You should have gotten 2 and 3 right next to each other inside the two lines, and 6 and 7 right next to each other inside the two lines. Okay, now when you have your two lines and the transversal that intersects those two lines, and those two lines happen to be parallel, and anytime two lines are parallel, they're going to be marked with these two arrows. If the two lines are parallel, then whenever you have corresponding angles, so angle 1 and angle 2, if the two parallel lines cut by the transversal and you have corresponding angles, then those corresponding angles are going to be congruent. If you have two parallel lines cut by a transversal and you have alternate interior angles, so you have that Z, if the two lines are parallel, then alternate interior angles are going to be congruent. And with all of these postulates and theorems, it's only when the angles are formed by two parallel lines, as denoted by the arrows here. The next theorem is the consecutive interior angles. Remember, consecutive interior, they're on the same side of the transversal, right next to each other. Well, this one's going to be different than alternate interior and corresponding. This one says that if corresponding angles are formed by two parallel lines, then corresponding angles are not congruent, they're supplementary. And if you're trying to set the consecutive interior angles equal to each other, just highlight them. And then imagine if you pull them apart. Does this obtuse angle look like it would equal this acute angle? There's no way this obtuse angle and this acute angle equal each other. Just like a linear pair. When you have this acute angle here and you have this obtuse angle here, they don't equal each other. Their sum is 180 degrees. The next relationship is with alternate exterior angles. And if parallel lines cut by a transversal form alternate exterior angles, then those alternate exterior angles are going to be congruent. So anytime you can find alternate exterior angles, so even here, and the two lines are parallel, then those alternate exterior angles are congruent. And then the last one, if you have a transversal that's perpendicular to a set of parallel lines, then the really nice part about it is it's also perpendicular to K. So if this J, this transversal, is perpendicular to H, and these two lines are parallel, then J is also perpendicular to line K. And then, of course, all of your relationships are going to be true, so that all of these angles centered around the two lines are going to be right angles. Okay, now let's do a couple of examples. It says to assume that A is parallel to B. So that tells me that those relationships we just talked about parallel lines, are going to be true in this case. So if the measure of angle 1 is 82 degrees, what is the measure of angle 5? Pause the video and see if you know. Well, first step is to identify what kind of angle pair you have. Angle 1 and angle 5 are called corresponding angles, and when the lines that form corresponding angles are parallel, then corresponding angles are congruent. So what number is congruent to 82 degrees? 82 degrees. Okay, so using the same picture, pause the video and see if you can figure out the measure of angle 6 if you know the measure of angle 4. Okay, and you should have gotten 50 degrees because remember that 4 is 130. Oh, well, that can't be 130. That's acute. Let's just pretend that this was an obtuse angle. And then angle 6, since angle 4 and angle 6 are consecutive interior angles, and consecutive interior angles are supplementary when the lines are parallel that form those consecutive interior angles, then we know angle 4 is 130, and we know the two angles together are 180, so we would subtract that 130 from 180 to get 50. Okay, so applying the same principle that we just learned in that last example about consecutive interior angles and when the lines that form them are parallel, let's see if you can find the value of x with these two angles that are consecutive interior. Pause the video and see if you get what I get. And you should have gotten x is 20 because remember, these are consecutive interior angles, one right next to the other on the same side of the transversal, and consecutive interior angles have a sum of 180 degrees when the lines that form them are parallel. So we would subtract 120 from both sides of the equation, and we'd be left with 3x equals 150. Divide by 3, we'd be left with, oops, sorry, change that to say 180 minus 120 is 60, and we divide by 3, so we get x is 20. plug that back into this x here and make sure they do in fact equal 180 degrees. 120 plus 3 times 20 is 120 plus 60, which is 180 degrees. So we're good to go. Alright, so on your practice worksheet, I'd like for you to do the odds only, and then of course the answer keys are going to be up, and so are the videos if you need help.